In this video, we're going to look at an example of how to use truth tables to test an argument for validity. First, let's go over the general concept of what it means for an argument to be valid so we can see how that concept applies to truth tables. So remember that validity is the feature an argument has when the truth of the premises logically guarantee the truth of the conclusion. This means that all worlds in which the premises are true are worlds in which the conclusion is true. If the premises are true, the conclusion must be true. So how is this reflected in a truth table? Well, in the truth table, first we'd have to find all of the rows that have true premises. You have to make sure that those rows also contain a true conclusion. So if all rows where premises are true are also rows in which the conclusion is true, then the argument must be valid. So let's look at this example. This example contains two atomics, G and M. So that means we're going to have 4 rows to our truth table. That's going to exhaust the possible combination of truth values for G and M, true, true, false, false for G, and true, false for M. So let's start by filling in the truth values for the atomics for our 4-row truth tables. So true, true, false, false for G, true, false for M. So these 4 rows are the 4 possible setups that we could have. Now let's go to our connectives. This conjunction means both must be true, which is only in row 1. The tilde is going to flip the truth value of the G here. So it's going to turn true, true, false, false to false, false, true, true. Now let's work outward to the next connective. First we have a tilde that's going to flip the truth value of that conjunction there. Turn true, false, false, false into false, true, true, true. This disjunction here is going to be true if at least one of the disjuncts is true. So in rows 1, 3, and 4. And then the tilde is going to flip the truth value of the G in the conclusion. Okay, now how do we use this truth table to test for validity? Well, first, let's look at which rows have true premises. So we're going to look for the main operator in each premise. In premise 1, the main operator is the tilde. Premise 2, the main operator is the wedge. So it means in premise 1 is true in rows 2, 3, 4. Premise 2 is true in rows 1 and 3. So the only row that has all true premises is row 3. So now we check to see if the conclusion is also true in that row, and it is. So that means all rows that have true premises are also rows with a true conclusion. So yes, the argument in this example is valid. So I hope that helps explain how the definition of validity connects to truth tables and how we can use truth tables to check for validity.